plus nk. That gives me 6 minus 15k, 6x minus 15k is equals to 4. So with this, I have a left hand side and a right hand side. This is my left hand side and this is my right hand side. So I will try to divide both sides of my linear equation by my HCF, which is 3. Dividing the right hand side gives me a positive, right? However, dividing my right hand side is impossible. It will give me, it's technically impossible, and therefore there are no current solutions to this congruence. If there are current solutions, that we will see when we are solving actual factual values. Now, when we're solving for linear congruences with solutions, so we are finding solutions to linear congruency statements. For example, in the statement ax congruent to b modulo n, we want to find the solution to this linear equation. It's the same thing as finding solutions to linear equations, like finding the value of x. So the only for linear congruences with solutions, we will have to find the HCF of integers a and n, where the value of n is greater than 1. The congruency will have solutions if b is divisible by the HCF of d. Here we said we didn't have any solutions because this b was not divisible by our HCF. And as we said here, we're going to let our HCF be d. So in the event that our HCF is able to divide b, then our congruency statement will have a solution. A point to note is that this is only applicable where the values of a, b, d, and n are all integers. I will give an example. An example is solve the linear congruence 12x is congruent to 16 modulo 20. So the first step is to determine the HCF of 12 and 6, which are our values of a and n respectively, and definitely it is 4. So we're going to let our 4 be d, and therefore going to divide both sides of our congruency statement by 4 and simplify equation to be 3x modulo congruent 4 modulo 5. So a trick to note here